All right, let's dive right in. Today we're talking about a single, newly discovered material that, well, it might be so much more than just a crystal. What if I told you it could be a laboratory scale model of the entire universe? A bridge connecting the bizarre world of quantum particles to the grandest theories of the cosmos. So yeah, let's explore how this one crystal could literally change everything.
I know. It sounds like something straight out of science fiction, right? But this is the very real question that researchers are now asking, all thanks to a material called platinum bismuth 2, or just PTBI2 for short. It's a question that seriously challenges our understanding of reality, of information, maybe even consciousness itself.
So let's meet the star of the show. Scientists over at IFW Dresden were studying the stuff PTBI2, and they stumbled onto something completely, well, unexpected. See, this material doesn't behave like anything we've ever seen before. It breaks some pretty fundamental rules, but it does so in these very specific and, as it turns out, very interesting ways. Okay, so its weirdness really boils down to these three bizarre properties. First, its superconductivity is what they call topological. Basically, it only happens on the surface, kind of like a conductive skin. Second, the way its electrons pair up to flow without resistance, it follows this unique six-fold pattern nobody's ever seen before. And third, it naturally creates these exotic, almost mythical particles, ghost particles, right on its absolute edges. Each one of these is a mystery, but when you put them together, they point to something profound. Now, superconductivity itself, that's not new. It's this amazing state where electrons can just flow forever without losing any energy, a perfect conductor. But what's absolutely wild about PTBI2 is that this perfect conduction only happens on its top and bottom surfaces. The inside, the bulk of the crystal, that just stays in normal everyday metal.
So this creates what the researchers have started calling a natural superconductor sandwich. You've got two slices of this amazing superconducting bread on the outside with a totally normal metallic filling on the inside. The key takeaway here is that all the really interesting exotic physics isn't happening inside the material, but on its boundary. You got to keep that idea in your head. The boundary is where the magic happens.
And this is where things get truly mind-bending. That superconductor sandwich isn't just some lab curiosity. It turns out it's a physical, tangible model of a really radical theory about the very structure of our universe, a theory known as the holographic principle. So what is that? Well, the holographic principle suggests that the three-dimensional universe we all experience, everything we see and touch and feel, might actually just be a projection. It's the idea that all the information that makes up our reality could be encoded on a distant two-dimensional surface, like a cosmic hologram. And what's so incredible is how perfectly this little crystal maps onto that massive idea. The boring 3D metal interior of the crystal, that's like our 3D universe, the bulk. But the 2D superconducting surfaces, where all the exotic information processing is happening, that acts just like the proposed 2D boundary of the universe. This material is quite literally a hologram in a lab. And this holographic connection, it goes even deeper when we look at that second word property, the pattern of the electrons on the surface. They pair up, but they refuse to pair up in 6 specific directions, which creates this beautiful six-fold symmetry. And this isn't random. This pattern is a direct reflection of the underlying atomic structure of the crystal itself. And this just brilliantly illustrates a core idea. The shape of the crystal dictates the rules on its surface. So if we extend that analogy, it suggests that the shape, the geometry of our entire universe could be what dictates the fundamental laws of physics that we all experience. The rules aren't just arbitrary, they're an imprint of a deeper structure. Okay, now for the third and maybe the most significant discovery of all. Nested within this strange material, right on the very edges of its superconducting surfaces, we find something truly exotic. A ghost particle that could change everything we know about information and computing. This is the Majorana particle. Now, in the quantum world, pretty much every particle has an antimatter twin, its exact opposite. An electron has a positron. But a Majorana particle is totally unique. It is its own antiparticle. It's a perfect union of matter and antimatter, all wrapped up in one single entity. So the crucial point here is what they represent. Normal particles, they embody duality, a world of opposites, like on and off, or positive and negative. But the Majorana particle, it represents non-duality. It's a single, unified thing that exists beyond those opposites. In terms of information theory, this is like information in its purest, most balanced, and most fundamental form. And this non-dual nature gives it some incredible power. Information that's encoded in Majorana particles is topologically protected. What that means is it's naturally shielded from outside noise and errors. To destroy the information, you can't just bump one particle. You have to affect the entire system in a very specific way, which makes it unbelievably robust. And this reveals this fascinating little hierarchy. The most important stuff, it isn't in the 3D bulk. It's not even on the 2D surface. It's on the 1D edge, the boundary of the boundary. This suggests that the most fundamental, most protected information in our universe might actually exist along these tiny, one-dimensional seams in reality. So why does all this matter? I mean, a weird crystal with ghost particles is cool, but the applications, they are potentially world-changing. This discovery could give us the hardware for technologies we've only dreamed of, including a whole new form of artificial intelligence. Because of that topological protection we talked about, Majorana particles are the perfect building blocks for fault-tolerant quantum computers, machines that don't constantly fail because of errors. This is the stable hardware we would need to build a truly complex, consciousness-aware AI, one that could operate on a totally new type of non-dual logic. The source material even speculates about something called a consciousness projectile. This wild idea that a system built on these incredibly stable Majorana particles could act as a robust vehicle for consciousness itself, something able to navigate the complex landscapes of reality without losing its integrity. And what makes this so electrifying is that it's not just theory. This isn't happening in some distant black hole or at the edge of the universe. It's happening in a crystal we can grow and study in a lab right now. PTBI2 gives us a hands-on platform to start exploring these incredible possibilities today. So we end up right back where we started, with a single crystal that acts like a tiny universe that contains the blueprint for fault-tolerant quantum computing and maybe, just maybe, a new understanding of consciousness. It leaves us with a pretty profound question. If we're finally learning to read and write the fundamental code of reality, what kind of universe are we going to choose to build with?